Hey folks, I think we are live. Let me just check the audio for a quickly. Let me just check audio and see if everything is all right. If everything is all right, we can. Hey folks, I think we are live. Yeah, I think the audio looks good. Yeah, my team is also checking the audio. I think it's perfectly all right. Sounds good. So let's wait for others to join in today. Today we'll be discussing a bunch of very interesting problems from control statements and functions. So bunch of very interesting problems. And I have a couple of announcements to make. So let's wait for, since we are ahead of time. Hey folks, good evening. Thank you for joining in. So we'll wait for a few minutes. It's not yet 7, but I came in slightly early. A couple of minutes early. So yeah, let's wait for others to join in. And once we get started, I have a couple of announcements with because there is some confusion with the dates that I've put for C programming. So I wanted to clarify that. I think we should go back to how we did the data structures and algorithms for batch 1. Okay, I'll explain you that in detail. Okay. So let's wait for it. Sounds good. Hey, good evening, folks. Thank you for joining in. So let me just check here. Yeah, I'll keep the comments tab also open so that I can see some of the live chat. My team is also here today. So yeah. Yeah, I'm just waiting for others to join in. We'll wait till 7:03 p.m. And once we hit 7:03, we could get started. 7:03, 7:04. Let's get going from then. So before we go ahead, I think, yeah, since some of you are here, I've recently discovered this book. One of our teammates actually told me about this book called C in Depth by Srivastava and Srivastava. I also mentioned this in some of the videos. Really liked this book. I mean, I really enjoyed reading that book. Actually, I mean, nowadays I'm reading that book more than Cunningham and Ritchie. Because what I like about this book is, while Cunningham and Ritchie covers the whole C standard very crisply, very neatly, what this book does is it gives you tons of examples. Okay, because it's very easy to learn through examples, right? So that's what I really like about it. I'm fairly impressed by this book because I've never read it. I'm reading this book as I'm creating content for this course, so I'm thoroughly enjoying it. I mean, even the exercise problems in the book, they're really good. So I'm reading the book. Especially the best part that I like about it is the programs that are there. I think programming is something that you learn by doing, by looking at others' code. That's the best way to learn programming, right? So this book, C in Depth by Srivastava and Srivastava, I think it's a couple who wrote that book because one name is of a male, the second name is of a female, if I'm not wrong. And I really enjoyed reading this book. I mean, terrific. I mean, I'm very impressed. I mean, I'm surprised that I didn't know of this book. I think this book wasn't there when I was studying some 14 years back, 15 years back. So we had another book called Let Us See, I think. Okay, which was not that good, frankly speaking. Again, this is my personal opinion. Your opinion could differ. So those of you who want to solve more problems, I would recommend you solve problems from C in Depth. There's also a nice 3rd edition book. I just got it from Amazon a few days back. Very interesting book. I really liked, I mean, I'm enjoying reading that book. I also heard that he has written a book on data structures also, not algorithms, but data structures. Somebody is saying that you are behind on iOS. Hey, we are working. So the biggest problem, actually, we have an iOS app. The only problem with iOS is iOS takes forever to give you app approval. We have sent them, they've sent us back. So there's that back and forth going on with iOS, unfortunately. I understand that we plan to launch an iOS app. We have a crude app ready, just like the way we have for Android. It's a first cut version. It is functional. It is no way phenomenal. It's continuously improving it. The problem with iOS is I can't give you an APK file equivalent in iOS and ask you to install because iOS doesn't let you do that, right? So we are still struggling with iOS app. So Avnish, just call us. I mean, in case I just want to explain you anyway since you're here. So iOS takes a lot of time for the app to get pushed. There is always this back because they want us to write a native app. Writing a native app is very time taking. So we're just going back and forth with them, having some native logins, and they want to have Apple login, tons of crazy stuff that we're going with. I mean, I strongly recommend, if you're falling behind, I strongly recommend to use the desktop app if you can, because we have a Mac. So if you're a Mac user, we have a Mac desktop app also. We don't yet have an iPhone/iPad app. Okay, it's just taking us too much time to go through the app store. So, I mean, I cannot promise you anything because while we pushed out the app, it's still taking forever for us to get through it. There is always this roadblocks. Apple wants us to write native app. We don't want to write it because they're just too time taking. Implementing all the functionality will take forever. We're doing it back and forth, unfortunately. Avnish, my strongest recommendation to you is to please use our desktop apps or Android app if you have access to it. That's what I would strongly recommend, because I can't promise you anything about the iOS app right now. We have something ready, but you can't install it without going through the iOS app. Number one. Number two is, by the way, since you mentioned this, anybody who does not get a mail within 24 hours, please pick up your phone and call us. Okay, for any reason whatsoever, if you do not get an email back in 24 hours, but please wait for 24 hours. Okay, because there is a big list of mails that we go through in first come first serve basis. At any point, this is what we tell even for our applied AI course students, right? At any point of time, if you do not get a reply in 24 hours, please lift your phone and call us. It will reach one of us and we will respond back, and it goes through everybody, right? And it goes through, if one person doesn't lift it, it will go to the second person and so on and so forth, right? So please, this is for anybody. For anyone who is a course registrant, if you do not get a response in 24 hours, please lift up phone and call us. I will ensure, because if it doesn't get answered, it comes to me. So don't worry about it, okay? Oh, Ayush, good. So you got some 2 questions from Test-1 in your campus interview. Very good, very good. I'm happy about it. Yeah, very happy about it. So somebody is saying about post-increment. Okay, we have some examples today of post-increment. I'll cover post-increment because we have some examples today of post-increment and pre-increment. Post-increment is very simple. Suppose I have x equals to I plus plus. Okay, I have x equals to I plus plus. Now I will first be used in this expression and then incremented. Okay, first I is going to be assigned to x. Whatever is the value of I is going to be assigned to x, and then it will be incremented. Okay, that's all. That's all is post increment. Okay, by the way, if you have any specific code snippet that you're confused with, just send us an email, right? We'll answer you. Right? Again, it's almost impossible to answer every question in a live session. I'm happy that some of the questions that some of you had in the previous session, you emailed us, right? And we tried to respond to, I think we responded to all of them as soon as we could. Okay. So anyway, since we are 7:05, let's get going. There are a couple of announcements that I want to make before we get going. The first announcement is there is some confusion with the course content. So what we're doing is we are doing daily course content. Right now, what we have done here is, for example, if you look at pointers, right, we have given 2 dates, tomorrow and day after. So you don't know what content you're going to get tomorrow, what content you're going to get day after. Now, because when we did our data structures algorithms, we did not do it like this. We gave every day what is the schedule. And there might be small changes here and there. Okay, if I get too much content, or if I get too little content, I might add more content, or I might remove some content. Okay, so please excuse us for those minor changes, but we'll try and stick to it as much as we can. Number one, right? Okay, so yeah, please, okay, we'll come to that. So first email us, we'll get back to you. In case you don't get a response in 24 hours, please call us. Mridmoy, that you're asking, right? Because it's almost impossible, because I could be recording some video. If you call, I mean, that video is going to get spoiled, right? So please email us. We'll try and respond in 24 hours. That's a promise here. Okay. Again, going back to the discussion, where was I? I lost the thread of thought there. Yeah. So now what we'll do is every day we'll put the sections that will be covered every day. Number one, so that there is less confusion there. Number one. Number two is we will give you content of that day, because some students have requested us for that, before 8:30 a.m. that day. So for example, tomorrow's morning content that we will give you will be uploaded to the app by 8:30 a.m. that day. So that I'm just looking at the comments and smiling. So the reason for that is some of you are going to work, some of you are working in jobs, right? Because one of our students requested is in the last live session and also over email that he wants to watch these videos while he's commuting. I'm very happy you're doing that. you're utilizing your commute time. So 8:30 is my deadline. Our editing team, everybody, we have this deadline. So I would give the videos probably sometime before night itself. The editing team will edit all of them and upload everything by 8:30 in the morning. Doesn't matter which day it is, as per the schedule we'll go. But please understand that sometimes there might be a small subtle change. That's why we're not saying we'll finish C on 16th or 17th. We're saying from 17th to 20th we'll finish. For example, when we did data structures algorithms, right, for batch 1, what happened was some students were, again, we also track a lot of metrics on how students are watching videos, how many of them have completed the test, how many of them have started the test. We measure all these metrics. If you notice that too many students haven't watched the videos or too many students have taken the test, we might say, okay, we'll give you a couple of days or one day, please finish it and let's get going. Because I don't want to leave anybody behind. Okay, that's very, very important for us. I understand some of you are fast learners, some of you are moving fast, but it's also our moral obligation to take everybody together with us. Of course, if somebody is a laggard, okay, somebody is lazy, he's not watching videos, we give them one chance, two chances. After that, I can't help it. Okay, beyond a point, I can't help you. But we'll give you some chances like that. Okay, that's why we also kept the weekends free for you so that you can revise or catch up in case you're lacking behind. Okay, that's another thing. So yeah, so as one of my teammates is updating, as soon as the content is updated, we'll send an email and SMS to all. So we're still working on how to do it automatically and things like that. So probably we'll send it manually so that you have a confirmation that yes, the content is up for today. I can go read it. Okay, I don't want this confusion that okay, is the content up? Is the whole content up? Is partially the content up? I don't want that confusion for you. Okay, so we thought we'll streamline this process so that it's beneficial to all of us. And yeah, somebody is saying about Towers of Hanoi. I'm very happy you liked it. There is another point that I wanted to mention before we go to the practice problem itself. One data-driven observation that we made with tens of thousands of students that we see on Applied AI course, also on this, on the GATE course that we started observing is, if I make small videos, we see this is a very nice pattern that one of our data scientists and machine learning engineers was mining this whole data, and he discovered that very interesting pattern. And this seems to make logical sense also. If I have, let's say, 5-minute, 10-minute videos, what happens is people watch a 5-minute video or 10-minute video, and then they take a break. Okay, the moment they watch 2 or 3 videos, they take a break thinking, oh, I have watched so much. Okay, so what's happening is there are more of those breaks and coming back, breaks and coming back, breaks and coming back. Okay, even though people have time, this happens even to me when I'm creating content, right? If I have a 30-minute video, that's why we are doing, if you notice more recently, based on this data, we are doing more 20 to 30-minute videos so that you sit on it, you finish the whole concept. And I also have a nice flow of logic there. See, if I have 10 minutes, I might miss out some points which I have to cover in the next video. So now what we are doing here is we are doing more of 20 to 30-minute type of segments so that once you start watching, you don't pause it, you finish the whole thing so that you cover the content in more, maybe 3 or 4 sittings a day. Okay, if I make it 10 minutes or 5 minutes, 10 minutes, 2 minutes, 5 minutes here, there, I mean, we see that more and more students drop out. Okay, so that's why we are creating more of these 20 to 30-minute segments so that once a student starts, he would spend that time to finish that whole video. And I'd also get a good chunk of time to cover all the details in a single video. Then they can go to the next video. So they can break their learning into 30-minute chops. Okay, I'll watch this video, which will be 20 to 30 minutes, then 20 to 30 minutes, etc. And this is something that we've observed in data. This is not our opinion or this is not our bias. Okay, so what is call by need and call by name? So Utkarsh is asking a good question. What is call by value and call by reference? We need to understand that in the context of pointers. That's why I haven't covered it in functions, right? There are some of these in-depth topics which require understanding of multiple concepts, which is holding us back. But at the end of it, we'll cover everything. Don't worry about it. Okay, at the end of the whole thing, we'll cover everything. If there is something, we will fix it for you, right? So somebody has a problem on string anagrams. Let's wait for strings, right? Strings are still below. We haven't yet done pointers and arrays and then strings, all the functions related to strings. We'll come there. But if you have a problem, just shoot us an email and we'll try to answer it, even if it's slightly early. Okay. So now let's get going into the test itself. Let me just change the screen. Screen share. Just a sec. Screen share. Okay, I'm sharing the screen here. You'll see a screen in a screen. Okay, so this is my, 1 second. Let's hide this. Okay, very good. So let's get going and let's start the problem solving. I'll just take a quick water break. Just give me a sec, folks. Just a quick water break. Yeah, I'm back. Sorry. So let's get going and solve this problem. Okay. So what is the output of the following problem? Okay, let's just scroll this problem. So what do I have here? I have a main function here, right? And okay, that's it. That's all I have. Main function with some for loop here, with some if condition, else condition, printf course. Okay, very good. So now let's go and see the options that I have for this, right? So this is the whole code, right? So what is the first one say? Compile error due to use of continue in loop. What is stopping you from using continue in loop? It's perfectly valid, right? We discussed about continue in loops and it's perfectly valid. In for loop, while loop, or do while loop, it's perfectly valid, right? So this option will not create a compile error. So this option is not true. No compile error, but it will run into infinite loop printing course. Why would it run into infinite loop? Let's see what's happening here. I equals to 0. Remember, for the for loop itself, your initialization could be an empty expression, right? We discussed this in the course videos. This could be an empty expression. Here also, the increment is also an empty expression. I have the increment here of this variable I, right? The check, the condition, the update is here. The update is actually not here. The update is here, right? And the condition check I less than 10 is here. Perfectly valid. Now I is less than 10. Yes. What would it do? It would print applied. Very nice. And it would increment I, right? So initially I equals to 0. Look at this. Initially my I equals to 0. Okay, I'll print applied. Then I'll increment I. So what will happen? My I, see, look at this. This I, I'm not using anywhere in the printf. I'm not saying %d anywhere. But this expression will be evaluated, right? This is one of the arguments of the printf function, right? This argument is not being used here. That is perfectly okay. But this expression will be executed. So I becomes 1, then I becomes 2. Again, applied will be printed, so on and so forth. Again, when I is getting incremented, eventually I will reach a value of 10, right? I will become 9. When I becomes 9, everything will work. It will go into this loop. I is less than 10, everything will work. What happens when I equals to 10? When I equals to 10, this condition itself will fail, right? So this condition itself will fail. So you'll never go into the loop itself, right? So it's not actually going into an infinite loop. So second option is also incorrect. What is the third option? No compile error. It will print applied course 10 times followed by course once. Okay, so there is applied here. There is course here. Why would it print applied course 10 times and course once? No, why would, see, because this whole thing is in the for loop. Look at this. This whole thing is in the for loop, right? So your applied course will be printed 10 times. Once when I equals to 0, second time when I equals to 1. How many times are here? Look at this. From I equals to 0 to I equals to 9, there are 10 times, right? There are 10 times. So this whole loop, applied course, you see, in this if else condition, I'll print applied. This continue will never be executed. Once I come out of this if else statements, I'll print course, right? So I'll print applied course 10 times. Why would I print applied course 10 times and course once more, right? Because this loop itself executes 10 times, right? So what will happen here is no compile error and it will print applied course 10 times. So option D is the right option here. Okay, very simple. I just went through the 4 options and I eliminated these 3 options. Actually, even if you don't eliminate, if you just execute this code carefully, your I will start from I equals to 0 because I have this increment here. It will keep getting incremented, right? That's it. 10 times it will print applied course. Option D is the right option here. Straightforward question, right? So now let's go to question 2. Again, some of these questions are easy, to be honest. They're not very hard. Okay, there are a couple of questions which are harder. Okay, so let's go to this question. So consider the following recursive C function that takes 2 arguments. Unsigned int foo, the function is called foo. It takes unsigned int n, unsigned int r. If n is greater than 0, okay, so it is computing this and then it is calling foo recursively. Look at this. Within the function foo, I'm calling function foo again, else return 0. Now the question is, what is the return value of function foo when it is called with 876 and 10? So let's actually write down. right? I have foo 876 comma 10. Now your n is 876, your r is 10, right? Now n is greater than 0, yes, n is greater than 0. So what should it return? So this will return n modulo r. What is 876 modulo r? 6. Because if I divide 876 by 10, I'll get a remainder of 6. So what do I have to return? I have to return 6 plus. See, this is my return, right? I have to return from this function, I have to return 6 plus. Again, it's calling foo internally. So what is it calling? It's calling foo, this function foo, with n by r. So 876 by 10, look at this, both are integers. So 876 by 10 will be 87, as we discussed earlier, right? In the course videos. And then I have r here, so this will become 10, right? So what would this function return? Look at this. This function was called with 876 and 10. What would this return? This would return 6 plus whatever this function returns. Now, what would this function return now? Let's go and evaluate that, right? So what would this function return? Now, my n becomes 87, my r becomes 10. N is greater than 0, yes. Return n modulo r. What is n modulo r? 7 plus, again call the foo. Okay, I'm again calling the foo function. What would this function return? This function would return 7 plus foo, 87 by 10. 87 by 10 is 8 because this is integer division. And I have r, the same r. Which means now to return back to this function also, I have to evaluate. Now how do I evaluate this function? Now what do I have? N equals to 8, r equals to 10. Is n greater than 0? Yes, n is greater than 0. So what would this return? This will return n modulo r. What is 8 modulo 10? 8 plus foo of, what is 8 by 10? 8 by 10 will be 0 because it is integer division, comma 10. Now what happens? Now your n equals to 0, right? So now n is not greater than 0, it is equal to 0. So what would it return? It would return 0. So this value, okay, let me just strike that off, right, with a different color. So let me just strike that off. So this value is equal to 0. So 8 plus 0 is 8. So this function, now this 8 is what is returned to this. So this will be replaced with 8 because that's what I'm returning here, right? Then 7 plus 8 is 15. This 15 is returned to this function, right? See, look at this. I'm going backwards. The winding and unwinding of recursion, right? Now I have 6 plus 15, which is 21. So 21 is now returned back to the main function if it calls foo with 876 and 10. Right? So this function is literally adding the digits that you have. That's what this recursive function is literally doing. Okay? If you have to ever write a program, look at the elegance of it. It's literally like 5 lines of code. If you ignore this parenthesis, 1, 2, 3, 4, 5, just 5 lines of code. That's the elegance of recursion, right? You are summing up these 3 digits with literally 5 lines of C code. That's terrific. I mean, I love recursion personally. When I was an interviewer asking interview questions, recursion, again, not just for me, but for many interviewers at top-notch product-based companies, recursion is their favorite thing. Okay, so the answer here is C, right? Very simple. I just went through and I've just basically winded and unwinded the recursion. That's all I have done. Okay, simple question, straightforward. Now let's go to question 3. Sorry, so this is question 3. Yes, this is question 3. Now let's see what is question 3. What will be the output of this program? Okay, let's scroll up a little. Okay. So let's scroll up. Okay. So what is the output of this program? I'm given this program. I'm calling this function foo from main. What is the input here? The input is 1 plus 1.8. This is the input, right? So what is 1 plus 1.8? See, there will be typecasting that will happen here. This will be 2.8. But the function foo takes integers. Look at this, the function foo takes an integer. So there is an implicit typecasting that will happen from, see, this expression is evaluated and you'll get 2.8, which is a float. But there is an implicit typecasting because this function foo takes an integer. So x here will become 2. Okay, because of the implicit typecasting that we discussed about, right? Now what happens? Now switch x equals to 2. So I'll go to case 2. This is constant, very good. So it will print A. It will print A. Then there is no break here. Look at this. There is no break here, which means after this line is executed, I'll go execute this line, which is T. Then I'll go execute this line, which is E. So what would this print? This would print A, T, E. That's all. If you have understood how switch works, you can solve this. This is a simple problem. This is a fairly simple and straightforward problem. Okay, ATE is simple, straightforward. Now let's go. So option B is the option there, right? Yes, option B is the right option. So now let's go to question 4. What does question 4 say? What will be the output of this program? Okay, let's go and check out this problem also. What do I have here? I have a main function here. I have a for loop here. I have a for loop in a for loop. This is the nested for loop. This is the 2 nested for loop within a for loop, right? So let's see what happens now. Okay. So int ij char value equals to a. Okay, look at this. This char value is of type integer, to which I'm giving a character constant. So what will it store? The char value will store the ASCII value of character A, capital A. Okay, to store the ASCII value of capital A, because it's of type integer, right? So now what will happen? Int I equals to 5, I greater than equal to 1, I minus. So what will happen? First I will be equal to 5. Look at this. First I will be equal to 5. Then what will j be? J will be equal to 0, j less than I, and it will keep getting incremented. First I'll have j equals to 1, j equals to 2, j equals to 3, and j equals to 4. The moment j equals to 5, j will become equal to I. Okay, so these are all the cases that will happen because j is getting incremented by 1. Right? Look at this, j plus plus. So each of these times what will happen when j equals to 0, what happens? I'm printing char val plus j equals to 0. Now what is stored in char value? The ASCII value of character A plus 0. Right? What do I get? I get the ASCII value of character A, which I'm printing as character. I'm not printing as integer here. Look at this. I'm printing as character here. So it will print A. Okay, next, when j equals to 1, look at what happens. Look at what happens when j equals to 1 here. Okay, when j equals to 1, I have the ASCII value of A plus 1. If I take the ASCII value of A plus 1, I'll get the ASCII value of B. Because I'm printing here character, I'll get B here. So this line will print B. This will print C. Similarly, this will print D, and this will print E. Okay, when I equals to j, right? When I equals to j, look at this. Once this whole loop happens, I get \n. So it literally print A, B, C, D, E, and then a \, which means I'll come to the next line. Look at this. After %C, I don't have anything. I just have a space. So after A, I'll have a space. After B, I'll have a space. After C, a space. After D, a space. After E, a space, and then a new line. Okay, now let's look at what will happen when j equals to 4. Okay, look at this loop, because j is going to get, when I equals to 4, not when j equals to 4. When I equals to 4, what happens? Because look at this update. I is getting decremented, and this will happen as long as I is greater than equal to 1. Okay, now I becomes 1. What are all the possible values of j? J will be equal to 0, j will be equal to 1, j2, j equals to 3. J equals to 4 is not valid, because look at this termination condition, j less than I. If j becomes equal to I, this condition will fail. Now again, when j equals to 0, what will you print? You will print A, you will print B, you will print C, you will print D. So in the next line, you will print A, B, C, D. Similarly, when I equals to 3, you will print A, B, C. When I equals to 2, you will print A, B. When I equals to 1, you will print A. Same logic will repeat. So this is the final output that you'll obtain. Now let's look at all the options that we have and see which option is correct here. Yes, so this option is the right option. Option C is the right option here. Right? Very simple program. You just need to understand how this type of loops work. Right? If you understand how this twin loop or how this nested loop works, you're good. It's fairly straightforward one. You got to be slightly careful. That's it. If you're careful following the function flow or the control flow, if you follow the control flow, these problems are straightforward, folks. Okay, most of the C programs, remember, most of the C programs that you will encounter in GATE are actually the easy scoring problems. They're not very hard. If you understand the basics of C programs, this is, frankly speaking, trivial. Okay, there might be one odd problem which is hard. There might be one or two problems which are like very complex, but most of them will be straightforward. It's a very, very scoring subject. Okay, so now let's go and see this problem. Right, so what do I have a function called fun, in which I have a static variable I equals to 3. right? So again, I have this whole function here, and I'm calling function recursively. Look at this. I'm calling function within function recursively, and within the main function, I'm calling fun. Okay, so as soon as I call fun, the control flow will move here. The control flow will move here. Now what will happen? Int static int, this is I, right? Int I. So static means it will be created only once. Okay, now what happens? Printf %di. So what am I going to print? I'm going to print 3. And there is a space after this. So I'll print space. Very good. Next, if minus I. So what does it mean? So first I is going to be used in this. This is somebody asked about the pre-decrement and post-decrement, right? So this is the pre-decrement, which means first minus I will be applied, right? So which means I will first become 3 here. Look at this. This is not constant. This is just static. This is not constant. Some of you may get confused. This is not constant. This is just a static variable, right? Which means I can perform minus I here, right? Which means now what will happen to I? Now I will become 2, right? And if 2 is greater than 0, 2 is not equal to 0, which means it is true. So I'll call again function. I'll again call function now. Okay, so this is going to recursively call function. But next time when I call function, my static is not going to be initialized again because that's a property of static, right? The first time you call the function, it will be declared and initialized. From the next time, it will not be initialized because it's already present in the memory now, right? So my I now is equal to 2. So I'll print it. I'll get 3, 2. I'll print 2 now. Minus I. What will happen now? I will become equal to 1. When I becomes equal to 1, if 1 means true, right? So again, I'll call function recursively now, right? So I'll recursively call function now. Again, I'll say printf I. My I is now equal to 1. I printed it. Now minus I. So I would now get decremented to 0. First, because this is prefix. Look at this. This is pre-decrement, which means first I is going to be decremented and then used here. So if 0 means false. Since it is false, I will not call function again. I will simply keep returning back. Look at that. Look at the recursion. The recursion will keep returning back, right? Finally, I'll return back to my main also, and I'll terminate the program. So the output right now, which I've been writing here, is 3 space 2 space 1, which is option B. This is a very simple problem. As long as you understand how static works. The objective of this type of problem is to help you understand how static works. Okay, if you understand that static is initialized only once and the memory for it is allocated once, and across function calls, the value will be retained in memory, you got the problem, right? Simple, straightforward problem, nothing rocket science here. Okay, now let's go to, so which problem is this? This 5, right? So let's go to 6th problem. Okay, so let's see what happens in the 6th problem. Okay, what is the output of the following program? Okay, somebody asked about pre-decrement and post-decrement. So let's check this out, right? So int main, I equals to 0, j equals to 1, and k equals to 0. Very good. If plus k, so this is my initialization. What does plus k means? K will become 1. Right? Okay, sorry, there is this if. This is not for loop. I'm sorry, I'm confused. Sorry, this is the if, right? So what do I have? I have plus k, I have j, and I have I plus. What is my initial value of I? I equals to 0, j equals to 1, k equals to 0. So this is basically comma separated terms. What happens when you have comma separated terms? These terms will be evaluated from left to right, and the eventual value of this expression will be the rightmost expression's value. Okay, so what happens when I say plus k? This will result in k becoming 1. J, what does j mean? J equals to 1 anyway. So you get 1 comma 1 comma. So what do I get? I get 1 comma 1 comma I plus. This is, look at this. This is post increment, which means use I here first and then increment it. To use I here, I value equals to 0. After I have used I here, after I've used this I's value of 0 here, I will increment I to 1. That's what the post increment does. Somebody asked in the comment in the live chat right now, right? First I will use it here and then I'll increment it. Now, if I have comma separated terms like this, we discussed this when we discussed about comma separation, right? So what is the result of this? What is the result of this? The result of this is the rightmost term because comma separated terms are evaluated from left to right And the eventual value of this is 0. So if 0 means it's false, because 0 means false. So this printf will never be executed. So this program actually prints nothing. This program prints nothing, right? So this, see, I also got confused. I thought this was actually a loop, because there are these 3 parts, right? We get, as soon as I see 3 parts, I say, oh, okay, I have to be careful for semicolon. In for loop, I have semicolon, right, between each of my terms or each of my expressions. I have a semicolon here. I have a comma here. So this is actually comma separated. This is literally comma separated expression that we have to evaluate. You've got to be careful, right? I almost made a mistake here. Okay. So let's be careful there. Okay. So this is question 6. Now let's go to question 7. See, some of these programs, if you know the concept, they're straightforward out there. So let's go for this. Int main. Okay. Let's look at this code. Okay. So what is happening here? What is it? Okay, compile errors, prints, etc., etc. Let's see what happens here. Let me just scroll down a little so that I can see the options also. Okay, so we have the options also. This is my main function. Let's see what's happening here. Int I equals to 1 j. All the 3 expressions, the initialization expression, the condition expression, and the update expression are empty. Okay, that's perfectly valid. Nothing stops us from doing that. If I, now my I equals to 1. Right, my I equals to 1. So if 1, what should we do? If 1, right, my I equals to 1. Yes, if 1, I'll go and do this. So here what happens now? Right, because my I equals to 1 right now, my j equals to minus I, which means what is happening? My I is becoming 0, because see, look at this. This is pre-decrement, which means I will become 0, and that final value of 0 is going to be assigned to j. So j will become 0. Okay, because I is not 0 initially, I is 1, we executed this line. Next line is if j is less than 10. Yes, j is less than 10. Printf applied course. Okay, so we'll print applied course once. Okay, look at this. And then j++ is also there. Okay, so what happens now? We print once, we print applied AA course once. Okay, then j gets incremented to 1. Okay, look at this, j++ is not being used anywhere here. Okay, but since it's a printf, each of these arguments of the function would get executed, right? So now applied course got printed once. Let's count it. It got printed once, and now j became 1, right? Now since j became 1, this is my whole for loop, right? Look at my for loop. Okay, so I go back up. Now what happens? If my I is 0, so I'll not go into this loop. I'll not go into this if condition anymore, because my I equals to 0 now, right? Is j less than 10? Yes, j equals to 1 now, j less than 10. Again print it once. Okay, again print applied course once, second time, very good. Then j becomes 2, j++, right? Now j becomes 2, very good, right? Again, the loop continues. I is still 0, so this part will never get executed now. J less than 10, because j equals to 2. This will keep happening. Look at this. This will keep happening till j equals to 9. This will keep happening till j equals to 9. When j equals to 9, what happens? J is less than 10, you'll again print. You'll again print once. This is, see, when j equals to 0, you printed once, right? When j equals to 9, you're going to print the 10th time. Look at the logic here. When j was equal to 0, you printed the first time. When j was equal to 1, you printed the second time. So on and so forth. If you follow this logic, this is always 1 more than this. This is always 1 more than this, right? So this is going to be 1 more than this. So you print the 10th time, then j becomes 10. When j becomes 10, what happens? Okay, there is nothing to check here in the for loop. J less than 10, no, j equals to 10, else you break. As soon as you break, you come to the next line outside the for loop. So what is happening here? There is no compiled error, and it will print applied course 10 times. Option C is the right option here. Okay, I just followed the logic here, nothing more. I just went step by step, carefully following the logic. That's all I have done here. Okay, simple, straightforward. See, as long as you're patient enough and careful enough, and if you know the syntax and the rules of C programming language, these questions are straightforward. Okay, so now let's go to question 8. Okay, so now let's go to question 8. Let's change the colors. I'm a little bored with the green. Okay, so consider the function. If a and b are 2 non-negative integers, then the call find a comma find a comma b can be used to find what? Okay, I'm given this function here. Okay, what am I calling? I'm calling find a comma find a comma b. Okay, what is there in the function? It's basically using this ternary operator which compares x and y. If the formal parameters are x and y, it is computing is x less than y. If so, return 0 or else return x minus y. There are two cases here, right? So it's asking, what does this return? Does it return the maximum of a and b, minimum of b and a and b, sum of a and b, positive difference between a and b? Let's check it out. But see, what is happening here? It's comparing x and y. So let's take case 1. Let's write two cases. Case 1. Let case 1 be a is less than b. Let's say a is less than b because that's what is important here, right? This is what is used to decide whether you're going to return 0 or x minus 1. Okay, first case is this. What happens now? First, I'm going to call find a comma b. Now to call this outer function, first I have to call this inner function. When I call find a comma b, what happens? A is less than b. Okay, now value of a gets copied to x, value of b gets copied to y. So x is going to be less than y. What does it return? It returns 0. Okay, so what happens now? Now I'll call find a comma 0. Right? Look at this. I'll call find a comma 0. Now it is mentioned that a and b are non-negative numbers, which means a is going to be greater than 0, which means x is going to be greater than y. Right? X is going to be greater than y, which means what would it return? It would return x minus y, which means a minus 0. So this would return finally a minus 0, which is equal to a. Case 1. Case 1 is going to return us a. Let's write case 2. Case 2 is a is greater than equal to b. Now let's see what happens. When a is greater than equal to b, what happens? Okay, let me change the color here. Can I get a darker? Okay, let me look for, okay, let's use this color. Okay, let's use this brownish color. Okay, if a is greater than equal to b, what happens? Again, my function is find a comma b. Okay, look at what happens. A is greater than equal to b. First, I'll evaluate this function because without evaluating this function, I can't evaluate this function, right? Find a comma b. Okay, now what happens now? A is greater than equal to b, which means this condition will be false. If this condition is false, this is what it will return, x minus y. So this will actually return a minus b. Very good. Now what am I calling? Now this function call will be equal to find a comma a minus b. Now since a and b are non-negative integers, a is going to be greater than a minus b. Look at this. Here a is x, a minus b is y now. Right? A is greater than a minus b, which means this condition is again false. If this condition is false, it will return us this. So what does that mean? It means it returns a minus b, which is equal to b. Right? So in the first case where a is less than b, it returned a. In the second case where a is greater than equal to b, it returned b. So what is it returning? It is returning the minimum of a and b. Right? The option B is the right option here. Right? That's what it's returning, right? A is smaller here, so it returned A. B is smaller here, so it returned B. Yes. Okay. So it's very important to answer such questions. You have to take these possible cases. And why did it take this case itself? Because that's the case that matters here, right? The return value of 0 or x minus y depends on this case. That's why I've taken these cases. If it depended on something else, I would have taken cases for that. Right? I hope this is clear. Now let's go to question 9. Okay, so let's again scroll down a little. It asks, what is the output of this program? Let's go step by step. Actually, this is a very good program. Actually, this is a tricky one. Okay, it's confusing. It's very fun actually. Very simple course. A very simple program. I have a character C initialized to A. Very good. Switch C. Okay, switch C, perfectly valid. Right? I have a variable name here. So what is C? C is A. Now look at these cases. Look at what I have here. In cases, what should I have here? We discussed in the course videos, right? You can have constants or you can have constant expressions. And this is constant expression because A is a constant and 1 is a constant. B is a constant, 1 is a constant. So these are constant expressions that are valid. But now there is a twist here. If you evaluate this, what happens? you will get the ASCII value of A, which is non-zero, logical and 1. So this will return, this will evaluate to 1, logical and no, this is true and this is true. Similarly, what happens to this? B is also a non-zero ASCII value. 1 also is one integer. So what is the logical AND of both of them? It will also return 1. So you have two cases in switch with the same value, which is not valid, which is an error, right? In switch case, you can't have case with the same value repeated again and again, because in that case, when you have this switch, it doesn't know where to go. If you have two cases with the same value, it doesn't know which case to go to. So this will actually result in a compile time error. This will actually return in a compile time error. Again, some of the details of why this will return in a compile time error, all of that, for most of you, we will learn that in compiler design. That's a brilliant subject. See, a lot of programming, right? Lot of programming internals on why this is happening. Why did the designers of C program designed it like this? Okay, for example, why did this result in a compile time error? Why should it? Okay, I gave you some logical argument here that yes, both constants. So when the program tries to decide which case it should execute, it's going to create an error. But you will understand all of them better when we study compiler design, where we understand how switch case is internally converted to machine level language. Okay, so compiler design is a terrific subject. One of my, I really enjoyed studying it in undergrad. Unfortunately, I have not used it much because I have not done systems programming myself much. I haven't built compilers and operating systems, but my understanding of C programming language improved massively after I studied compiler design. Okay, so many of these concepts, many of the whys behind these concepts will become clear when we learn compiler design. It's a terrific subject. Okay, so now let's see. So where are we? We are on question 9. Just give me a quick water break. I'm going thirsty. Just give me a sec. I'll be back. Okay, so now we are at question 10. So let's go through this question. So it says, what will be the output of this program? Okay, so let's go through this. Okay, so stdio, all that is nice. Int main. Okay, I have int I equals to 1. I have the do while loop here. Look at this. I have the do while loop here. So do while 1. Okay, your I is 1. While 1 means true. It will decrement I. So what will happen now? I will become equal to 0. As soon as I becomes 0, when I go to this while loop, okay, while 0, so I'll come out of this while loop, right? Next, what is happening here? I plus plus. Look at this, I plus plus, 0, I plus plus. Now, when it does I plus plus, first I'll use the value of I here. Look at this, I'll use the value of I here, and then I'll check this condition. This condition itself says 0. 0 means false, right? 0 means false. So the moment I make I plus plus, what happens now? Now I becomes 1. Look at this, I becomes 1. Okay, so I becomes 1 now. And then look at this condition. This condition says 0. There is no expression to evaluate. It's a constant 0. 0 means false. The moment it is false, what happens? This program, this line, again, there is a semicolon here. Observe that, which means nothing happens in this loop. Then there is a line called break. As soon as it encounters break, what happens? I'll come out of the loop. Now I'll execute this printf. Right? When I execute this printf, what is the value of I? I's value equals to 1. So it will print 1. So it will print 1. Then it will return 0. So what is the answer for this? 1. Some people may get confused and say, oh, I have a do while loop here with 1 here, so it might be infinite loop. No, you have to go through the logic. There is break here, right? To come out of the loop. So you have to see when will break get executed. Okay, so this is slightly tricky because of this case. This 0 is the tricky case, and this break is also there. So this will not actually go into an infinite loop. So the right answer is it will simply print 1. Simple, straightforward problem. Okay, if you go through step by step logically, you'll get this. Okay, most of C programming is like that. If you know the rules and if you go step by step, you'll get the answer. Okay, so now let's see what is this. What will be returned by the following function foo when we call foo12? What does the function do? It takes an integer, very nice. It returns n ampersand n. So this is bitwise and bitwise or. Okay. So what is 12 now? But let's write 12 in bitwise. 12 in bitwise is 1100. This is 2 power 0. This is 1, 2 power 0. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. 8 plus 4 is 12. Yes. Right? This is binary. So this is the binary representation of 12. Okay, now what does it say? It says n bitwise and bitwise or. So if you recall the precedence of operators, bitwise and has a higher precedence than bitwise or. So first we'll do n bitwise and n. So what is n? N is this. If I perform bitwise and this, what will I get? 1 1 1 1 1 1 0 0 0 0 0 0. So that's what I got if after I perform the bitwise and. So this part is executed. Now I have logical or 1. So I have logical or, what is 1? 0 0 0 1. This is logical bitwise or. Okay, this is bitwise. This is not 1. This is bitwise or. Okay, so let me write that. So if I take the bitwise or of this, what will I get? I'll get 1 1 0 1. 1 0 is 1. This is or, right? 1 0 is 1. 0 0 0 1. What is this in binary? This is nothing but 13, no? Because look at this. This last one, so this is 1, 2, 4, 8. 8 plus 4, 12. 12 plus 1, 13. So what would this return? This would return 13. So you can fill in the blank here. Right? Straightforward, simple problem. If you know how to convert numbers, and if you know, this is important, if you know, actually they should have given this slightly more tricky. I think the trickier would have been this. Because, or something like that, sorry, not like this. 1 or n and n. This would have confused people because a lot of people forget that bitwise and has a higher precedence than bitwise or. People will think they both have the same precedence and will do left to right. A lot of people have that confusion. Okay, so be careful with that. You have to remember the precedence logic. Okay, so now let's go to the 12th question. Okay, so what is the output of this C program? Okay, let's go step by step again. Again, same logic. Let's go step by step. That's all we care about. Okay, so include, okay, let me just scroll down so that I can see all the 4 options while I'm solving it. Okay, so that I can see all the 4 options. Int fun, int main. Okay, so this is the declaration. This function is defined here. Very good. So for, oh wow, this fun is being called in both initialization, condition check and update. Okay, let's see what happens. First, this will be executed. First, fun will be executed, right? First, initialization will happen, right? Then condition check, then I'll go into the loop, then update, then condition check, then go into the loop, so on and so forth. So let's start. In the first, let's go step by step, right? First, this function will be executed. When I execute this function, it will go here. There is no static variable, so it will create num equals to 10. Look at this. This is static variable and return num minus minus. So first it will return num and then decrement it because this is postfix operator. So it will return 10 here. First it will return 10. And here what am I doing? I'm printing fun. So when I do this, what happens? It will actually, sorry, what is happening here? I'm taking this. Oh, sorry. I can't yet print it, right? Because I have condition check also. Sorry. So it will return. So here what would it return? It would return a value of 10, but num internally has changed to 9. It was, see, at the end of, let me write it actually. For the initialization, right, num was 10. But as soon as initialization happened, num became 9. Right? Num became 9. Right? Num became 9 now. Now at the function, for the function, what happens? Now this condition check will happen. Again, it will call this. What would it return here? It would return 9 here now. Right? So after num becomes 9, right? After num becomes 9, I have the, I have the check. I have the condition check. Right? I performed the condition check. This value here, it returned 9, right? It returned and then it decremented. It returned and then it decremented. Right? So because it returned 9, 9 is true. Because 9 is not equal to 0. So I'll go into the loop. But look at this. Look at this. When I go internal, again I'm calling function here. When I call function here, what will happen? See, here I'm doing a function call. Here this is my print. Within the print, I'm again calling function here. When I call function, what would it return? It would return 8. And then it would decrement to 7 because of the postfix decrement. So since this function got 8 as the output, it will print 8. right? It will print 8. Actually, you can stop here because if you look at the 4 options here, the only option A is the right option. Okay, you can just stop here. There are 4 options here, you can stop here. But if you want to go on, you can still go on, right? So now number became 7, right? Now, see, the whole trick here is to understand that first initialization happens, then condition happens. If the condition is true, you go into the function. Then again, a lot of people forget. Again, this problem was designed keeping in mind that after initialization, condition check happens the first time also. A lot of people forget this. That's why this function, that's why this tricky question was made. Okay, if you keep going on, it will actually print 8, 5, and 2. You can keep following this logic. What is the logic? From next time onwards, after this function body is executed, this will get executed. Once this is executed, we'll also make a check. Once check is satisfied, we'll go in. Then we'll go back here, go here, so on and so forth till the time the check becomes 0. See, because this number is getting decremented, at some point this will become 0. When that becomes 0, the condition has failed, and hence you'll come out of the loop, right? So you can just follow this logic and you'll get 8, 5, 2. Okay, but even by just answering the very first one, you're printing 8, right? So if you look at the options, A is the right option without even going too deep. Okay, see, in examination setting, time is extremely critical, right? As soon as you got the first one, nothing else has that option, just answer yes, done. Okay, my answer is done, let's move on. Okay, so this is your, this is 12, right? Yes. So let's go to question 13 now. Okay, so let's go to question 13. What is the output of this program? So let's see what is happening here, right? Int main, int I equals to 0. There is nothing to initialize, right? I plus plus, which means I is going to be used here first. Look at this. I have I plus plus in the condition. I have I plus plus, which means I is going to be first used here. What is the value of I? 0, right? The value of I is 0, right? The value of I here is 0. 1 second. I plus plus, right? First I is going to be used here. So I is going to be equal to 0. Yes. So, okay. Oh, there is a semicolon here. Okay. That was confusing. Okay. So I is equal to 0. Because there is a semicolon, this single line is the whole for loop. This is not part of the for loop. Okay. That's what I also got confused with. Okay. There is a semicolon here that you have to be careful about. Because there is a semicolon, the body of the for loop is empty. The body of the for loop is empty. Because this is 0, this for loop never gets executed. Right? This for loop never got executed. But after value of 0 is used here, I got incremented. So I became equal to 1. Because I was used here as a value of 0, and then I got incremented, which means I became 1. Next, because of this semicolon here, this loop was never executed. There is no body to it. Right? And again, the condition failed. Look at this, the condition failed, which means you'll never go into the body also. The body is empty and you would never go into the body. Okay, now look at this. Now, this is part of the main loop. This is not part of the for loop body. It's just confusing because of this space here, of this spacing, it looks confusing. So you got to be careful. Observe the column here. Observe the semicolon here, I'm sorry. Okay, now you printf I. When you printf I equals to 1, so it will printf 1. And then you return. So this is a slightly tricky problem. I almost fell into the trap. I was slightly careful to observe this because I was thinking, not because if it was not there, right, it would print nothing. But nothing is not an option here, right? So I almost fell into the trap. So you got to be careful and very careful with the function syntax itself. Okay, so it prints 1. Very good. So now let's go to 14. Okay, so let's see what happens here. Okay, this seems like a daunting task, but let's see. Assuming int size is 4 bytes, what is going to happen when we compile and run the following program? Okay, this is interesting. You have main function. I'm printing applied course. Look at this. I'm printing applied course and I'm calling main again. I'm recursively calling main. Is that allowed? Yeah, what stops it? There is no rule which says that main is some function which you cannot call recursively. So it will print applied course. Again, it will print applied course, so on and so forth. Let's look at the options. If you read the options, option D is the most valid option. Applied course will be printed until stack overflow happens for this program. What does stack overflow? I discussed this briefly in the videos. Okay, stack overflow is a concept wherein when you perform recursion, there is something called as a call stack. Again, we have discussed this in detail in our data structures and algorithms chapters. Right? We discussed how call stack works, because I didn't cover it in the C programming, because you need to understand this data structure called stack. Okay, in the data structures algorithms course, we have gone full depth into call stack, full depth. Okay, we talk about tail recursion. There are many advanced concepts about recursion that we've discussed there and not here, because that requires you to understand how stacks work, what is the time complexity, all of those things. Okay, for batch 1 students, you already know it. For batch 2 students, we'll come to data structures algorithms. Don't worry about it, right? So as these function calls keep happening over and over and over and over again, what happens finally? Because as I told you in the course videos, to make this recursive call, there is going to be some temporary data about the function that is going to be stored every time, right? So eventually, this will run out of memory and the program will terminate. The operating system will kill this program. Okay, so option D is the right option. This is not a compiler error or anything. You can call main recursively. That's what we wanted to send a message of, right? It's perfectly valid. Nothing stops us from doing it. Okay, so let's go to question 15. Okay, let's see what happens here. So what is the output of the following program? Very simple. Let's go. So I have the main function here. X equals to 3, y equals to 4. X less than y. Yes, x is less than y. Very good. Because 3 is less than 4. Very true. So I go in. It says return x equals to x plus y. Okay, it's literally returning the whole thing. What happens in this statement? It says x equals to, what is x and y? 3 plus 4. So this is in braces. So this statement will be first executed. When I execute this statement, what happens? X becomes 7 and 7 is returned here. This function now returns 7. That's it. Printf nothing. This will not work. This will not work, because you're already returning out, right? Right? You're simply returning out. So nothing will happen. So what will happen? Result in compile error? No. Course? No. It will not print applied course. It will not print anything. It will not print anything. It would return 7. Okay, that's all. Okay, because there is return here. Return can return from the main function also. Right? Because this condition is satisfied, we'll simply return. That's it. Okay, so some of these problems are simple. I hope you got a good sense of these problems. Let me just switch to camera mode. Okay, so I hope you got a good sense of these problems, and yeah, this was interesting. So as I mentioned earlier, we'll be pushing out content for the day before 8:30 a.m. positively, most of the content at least. And if there is more content in a day, we might just squeeze out a little, and we'll give you day-by-day content, in the sense that, so right now, for example, actually we did a better job with data structures algorithms. Right now, I think I should have taken more care. I do not want to give you date ranges for content. Instead of giving date ranges, I'll give you exact dates. On this date, this is the content that you'll get by 8:30 a.m. Then this is the content you'll get by 8:30 a.m. and so on and so forth. We're also working on sending you an SMS and an email as soon as all the content is uploaded. Again, we're still streamlining this. Please excuse us if there are 1 or 2 days delays here, because I record everything, give it to the editing team. Editing sometimes takes a lot of time if you have a lot of content or a lot of small videos, right? So just give us some time. We'll streamline this. I promise you, we'll streamline this. And it's not very hard. Our editing team has to just edit all the videos and upload it on time. And as soon as all the videos are up, we'll send you an SMS and email. I was just talking to our team right now, and they said they can do that. So that we are streamlined here. Okay. Again, please excuse us 1 or 2 days here. We'll surely streamline this everything by end of the week. Okay. Any questions that I could not answer in this live session, just shoot an email to us. And as I was mentioning to one of our students, if you do not get an email response in 24 hours, please pick up the phone and call the number that's there on the website. Okay. It'll keep daisy chaining. For those of you who know what daisy chaining is in operating systems, right? You'll go to one person. If that person is busy or could not lift, you'll go to the second person, so on and so forth. And I can see if there's any call that is missed by everybody, so that one of us can quickly go ahead and answer your calls. Okay. So thank you very much for joining in. Any questions that I could not answer in this live session, just shoot an email and we'll try and answer this. Okay. See you folks. Thank you for joining in. Next live session will be on Saturday. Okay. Saturday evening, same time, 7 to 8:30 p.m. And we'll do more interesting stuff around pointers then. Okay. Pointers is something that I'm very curious to go into. Pointers is the power of C. I mean, I love C for pointers. It's unfortunate that, I shouldn't say unfortunate also, there are some major drawbacks of pointers, which are relieved, or which are alleviated, or which are removed because of more advanced concepts called references in Java and Python. But I always enjoyed whenever I wrote low-level code. Like, I'll tell you where I used C extensively. I used C extensively at 2 places in my whole decade worth of career. First time I used it. Actually, I used it 3 times. Okay. First time when I was, it was a fun experience. So I was interviewing for Yahoo Labs or Yahoo Research, and this was straight out of IAC, and they asked me to write a very interesting program. I think I mentioned this is one of the, I think I mentioned this in one of the videos also. So you're given a big number, and I'm asked to compute the factorial of that number. Factorial of 1000. It's going to be many, many digits, right? It will not fit into int. It will not fit into unsigned int. It will not fit into unsigned long int. It will not fit into anything. How do you solve that problem? Okay, it's a very interesting problem, and I was asked to solve that. Any programming language of your choice. This was the coding round of Yahoo Labs interview for the machine learning, for the research or machine learning engineer role. Very interesting. It's a very mathematical problem, right? Very valid problem to give to a machine learning engineer or a research engineer. And I actually, because I was not very comfortable in programming languages then, because at IAC, I did hardcore math work. I wrote code in MATLAB, to be honest. I didn't write code in any major programming language. So the only language I was comfortable was C. I said, give me GCC, I will write code in Vim on Linux terminal, literally. And I finally implemented a very good algorithm. I really enjoyed that exercise. So that's one time that C really saved me. The second time was when I was doing a startup about, this is a very interesting startup about, this is around 2011, early 2012. So we were taking smartphones. This is again with a, we would take a smartphone video of your face or any object, and I would create a 3D model. This is huge math intensive work. There is a ton of optimization, ton of beautiful mathematics behind it. It's a computer vision problem. Tons of data. Imagine, I literally have a huge video and I have to do millions and millions of calculations very fast. So I ended up using C and C++ for that. That's a second instance where I use C++, because I was sitting on massive amount of data and I had to crunch all of that extremely fast. That's the second time. The third time I used C extensively was when I was at Amazon, and the team was building a system wherein I would get some query. I don't want to go into some specifics because of Amazon proprietary stuff. I was given some input and I have to give the output after running a machine learning model very, very quickly. Okay, I literally had like a few milliseconds to answer. See, look at this. I would get an input. An input is basically an array of numbers, array of floats. Okay, I would get this input. Within a few milliseconds, I have to run a machine learning model on this and give an output. Literally, I had like 3 milliseconds. So we sat with some of our best engineers at Amazon and we said, it was not working in Java. We wrote Java code. We wrote Python. Python is still worse. Okay, we said, leave all of this. Let's go to our basics. It's like C programs. So that's when we wrote C program and it gave us 1 millisecond delay. Because C is so, and we'll optimize the code like crazy. The C code, because it's so close to the memory, right? It's so close because I can access, again, we'll see that in pointers. I can literally access each memory location and be extremely fast. So we ended up coding a big chunk of our advertising system, machine learning systems in C, because we wanted an extremely fast thing. I also learned that most of the machine learning fleet, the serving fleet or the fleet, because imagine you're a part of the Facebook feed team, right? Wherein you have to run a complex machine learning algorithm to determine what article to be shown to you. Imagine it has to run for billions of people. It has to run extremely fast. So all those systems are actually, both at Google and Facebook, are actually built in C++. Mostly in C++, but C++ is nothing but C with something else on top, called object-oriented programming, right? So these are some fun experiences I had with C++. They've saved my life multiple times, right? So mostly C. I've enjoyed C thoroughly, personally. Anyway, so any problems, I just wanted to give a couple of anecdotes from my own personal career. And any questions that you have, please shoot them. I'm not looking at the chat window because I'm looking at the camera right now. So any questions that I could not answer, just shoot us an email and we'll respond back to you as soon as we can. See you folks. Have a good week and thank you for joining in.